Hi everyone, I am Zubair Hassan. Hope you all are fine. Today we are going to discuss a very important topic on parametric statistics and non-parametric statistics. So dear friends, let's move ahead on today's topic, parametric statistics and non-parametric statistics. At first, we will start with the concept of parametric statistics. Parametric statistics is the statistical assumption which assumes that the observed data are distributed based on normal distributions. Parametric statistics is the statistical assumption which assumes that the observed data are distributed based on normal distributions, or sample come from the population can be adequately modeled by probability distribution that has fixed set of parameters. Or we can say sample come from the population can be adequately modeled by probability distribution that has fixed set of parameters. Or parametric statistics are used to make inference about population parameters. Parametric statistics are used to make inference about population parameters. So in the last lecture, you may remember that we have discussed in last lecture what's the parameter and what does mean the statistics. So parametric statistics are used to make inference about the population, or we can say about those parameters of the population, and the scores which are parameterized by mean and standard deviation called as normal family of distributions. The scores which are parameterized by mean and standard deviations can be called normal family of distributions. Normal family of distributions. So this is the we can say concept of parametric statistics. And parametric test. Parametric test means which assumes normal distribution of values based on bell-shaped curve. Parametric test assumes normal distribution of values based on bell-shaped curve. First, we discussed parametric statistics, and now here it is parametric test. What does it mean? Which assumes normal distribution of values based on bell-shaped curve. Bell-shaped curve I have given here. You can got it through this bell-shaped curve. The distribution of known population to unknown parameters on which we want to make inference. Parametric test means the distribution of known population to unknown parameters on which we want to make inference. So this is the parametric test. And what are parametric tests? Parametric tests like t-test, Pearson product movement correlation, and ANOVA, or we can say f-test. In t-test, there are two paired and unpaired t-test. You know, paired t-test is during experimental studies, and unpaired t-test non-experimental studies. And Pearson product movement correlation, these are the statistical techniques, or we can say statistical tests which are applied in parametric statistics. And there are also some exceptions of parametric tests, like uh, like normally distributed, random independent samples, interval or ratio level of measurement, homogeneity of variance, large sample size, and statistical. These are the assumptions of parametric test. Parametric test is applied on normally distributed population and random independent samples, where there are random independent samples, and we can say interval or ratio level of measurements, and homogeneity of variances, or we can say large sample size. It can have large sample size, and it is statistical. And this was all about the parametric test, parametric statistics, and these are the assumptions of parametric test. And non-parametric statistics. Non-parametric statistics is not based on parameterized families of normal distributions. Non-parametric statistics is not based on parameterized families of normal distributions. It is either based on being distribution free. It is either based on being distribution free or having specified distributions. Non-parametric test has specified distributions. The population which does not rely on parameter estimations, the population which does not rely on parameter estimations is called non-parametric statistics. Is called non-parametric statistics. That population which does not rely on, we can say, which does not rely on parameter estimations, which does not rely on the normal distributions, which does not rely on, we can say, interval or ratio measurements, is called non-parametric statistics. And non-parametric statistics also called as order statistics. Non-parametric statistics also called as order statistics because it does not rely on interval and ratio level of measurements, which are based on rank observations. Here, rank observation means non-parametric statistics relies on the nominal and ordinal scales of measurement. Nominal and ordinal scales of measurement. So far as it's also called order statistics. It's also called as order statistics. So this is the concept of non-parametric statistics. Now, non-parametric test. What does it mean? Non-parametric test is also known as distribution free test. Non-parametric test is also known as distribution free test. Means there is no normal distribution of the population. Non-parametric test does not assume anything about the underlying distributions. Non-parametric test does not assume anything about underlying distributions. Underlying distributions, like I have given an example with a graph of histogram here. There is no, we can say, a normal distribution of the population in histogram. You know, the population which does not rely on normal distribution, which relies on nominal and ordinal scales of measurement, is called, we can say, on which we are going to apply non-parametric test. So this is the meaning of non-parametric test, and this was the non-parametric statistics. And now non-parametric, the assumptions of non-parametric test, like not normally distributed, as in parametric test. The population is normally distributed, and random assumptions, we can say, and random independent samples. Similarly, in parametric tests, there is also random independent samples, but nominal and ordinal measurements. In parametric test, there is, we can say, interval and ratio level of measurements, and in non-parametric test, there is nominal and ordinal measurements, and less statistical power. Non-parametric statistics has less statistical power, or we can say non-parametric test has less statistical power or more conservative. Non-parametric test is more conservative and small sample size. There can have a small sample size. These are the assumptions of non-parametric test. And non-parametric tests like chi-square, median scale, Spearman correlation, also known as rank order correlation. There are also some non-parametric tests, but I have given some tests on here. So this was all about parametric test and non-parametric tests. I hope you got a proper understanding. But difference, I have given the difference of parametric and non-parametric statistics on its classification. Some classification like data type, usual center measure, correlation tests, how it is used, what tests are used in parametric and non-parametric statistics. Like data type, we can say data type, I mentioned it here, ratio or interval scales of measurement are used in parametric statistics to apply on the data, and we can have the measurement in ratio or interval scale of measurement. And in non-parametric statistics like ordinal or nominal scale of measurement and usual central measures. The usual central measures of parametric and non-parametric statistics like the mean, is used in parametric statistics and the median is used in non-parametric statistics. And correlation tests like Pearson product movement correlation I have also mentioned before. You have seen in parametric statistics the correlation test like Pearson product movement correlation is used, and in non-parametric statistics like Spearman rank order correlation is implied. And independent measure two groups, like whenever there are independent measure of two groups, independent measure t-test can be applied. And in non-parametric statistics, independent measure of two groups mean y test can be applied, and independent measure more than two groups when there are independent measure of more than two groups. What can we do there, or what test can be applied? One-way independent measure ANOVA. One-way independent measure ANOVA can be applied. In non-parametric statistics, Kruskal-Wallis test can be applied. And repeated measure two conditions like in parametric statistics, matched pair test can be applied. And in non-parametric statistics, Williamson test can be applied. And also repeated measure more than two conditions. When there are more than two conditions in repeated measure, one-way repeated measure ANOVA can be applied in parametric statistics. And in non-parametric statistics, we can say Feynman's test can be applied. So friends, this is very important in this table. It is very important and necessary knowledge. I think you should note this, or you can also have it screenshot. It's very important for you uh, about parametric and non-parametric statistics. So friends, this was all about the parametric and non-parametric statistics. I hope you got clear understanding of the parametric and non-parametric statistics. So thank you.